Start. So the very first heading in this today's session on work, energy and power, okay, we will be discussing about the law of conservation of energy first. Okay, so I'm writing here
Okay.
about the law of conservation of energy. So do you know what is law of conservation of energy?
I think it's like energy is it cannot be made or destroyed.
Yes,
Like it
very
just
good.
gets transformed from
Very
one
good.
form to another.
Yes, we studied this law, I think, in the previous class as well, in class ninth. It's just similar to the law of conservation of charge, law of conservation of momentum. Okay, so law of conservation of charge
Okay.
says that charge can neither be created nor be destroyed, right? Law of conservation of
Yeah.
momentum says that the momentum basically remains conserved. Okay, whereas the what is the law of conservation of the energy? What it says, energy can neither be created nor be destroyed, but can be transformed from one form to another form. Okay, that is your law of conservation of energy. Clear about this?
Okay.
So if someone asks you what
Yeah.
is law of conservation of energy, what you are going to tell them? Simple statement. Okay, according to it, according to law of conservation of energy, so energy can neither be created nor be destroyed. Okay,
Okay.
but but can be transformed transformed from one form to the other form. So this is called as what? Law of conservation of energy. Okay, in simple words, total energy, okay, of an object always remains constant. Clear about this? It will always remain
Yeah.
constant. Okay, so there are many examples to the law of conservation of energy. Okay, many examples are there for the law of conservation of energy. The very first example which I'm going to use and which is also given in your book, okay, is what? In law of conservation of energy. Okay, so if I give you the example, the very best example, you can take any example. Okay, there are hundreds and thousands of examples which we have seen in the previous classes. Okay, conversion of electrical energy into light energy, into sound energy, into heat energy, conversion of potential energy into kinetic energy, and vice versa. So we have seen different energy conversions, isn't it? Tell me.
Yeah.
Okay, so basically as we have seen different energy conversions, so yes, you can actually write anything. Okay, for example, let me give you one example: a wound up watch spring. Okay, so basically when you wound up the spring, so at that time what happens? There is an elastic potential energy in the spring. Okay, and when you unwound the spring, what happens? The elastic potential energy is converted into the kinetic energy. Okay, and it is because of this that the hands of the watch are moving. Okay, clear about this? Okay,
Yeah.
now another example is basically, suppose the stone is at some height, let us suppose. So basically at some height the stone will have the gravitational potential energy, right? Okay, now let us suppose
Okay.
at the bottom, I am giving you the example here. Okay, suppose this is your stone at some height. Okay, this is your stone. Now this stone is being dropped at some height, from some height. Okay, and below this there is a nail. Okay, it is dropped on a nail which which is on the board, on some wooden board. Okay, this is your wooden board. What will happen? Wooden board. Okay, so when this is uh, this stone will be dropped on this, so at the height it has the potential energy, maximum potential energy, because potential energy is because of the height. Okay, so it has the maximum potential energy, but kinetic energy is zero. And when it will be allowed to fall, what will happen? Tell me. The potential energy will be converted into kinetic energy, and with this kinetic energy, maximum kinetic energy, it will fall on this nail. and this nail will get embedded into the wooden board. Okay, clear? Understood?
Yeah.
Okay, so I'm writing the example so that you can understand that. Very easy example. So one or two examples I will write so that you can understand. Okay, so for example, a stone at a height has a gravitational potential energy. Understood? Due to its raised position. Due to its raised position. Okay, due to its raised position means due to its height. Clear?
Yeah.
So what will happen then when the stone is made to fall on a nail? Made to fall on a nail standing on a wooden piece. Standing on a wooden piece. So what will happen? Tell me. The nail begins to penetrate. The nail begins to penetrate. Understood?
Yeah.
What was the reason? The reason is that as the stone starts falling, what will happen? Its potential energy converts into kinetic energy. Yes or no?
Yeah.
Begin to change into kinetic energy. The falling stone now has the kinetic energy. Okay, when it strikes the nail, what will happen when it strikes the nail? The kinetic energy of the stone work on the nail. Clear? It will work on the nail. Okay, and what will happen afterwards? The kinetic energy of the stone changes into the kinetic energy of the nail. Then changes into kinetic energy of the nail. Okay, due to which nail moves into the wooden board. Nail moves into the wooden board. I hope you have understood this. Very easy. Okay.
Mm-hmm.
So let me make a little space here. So this is your law of conservation of energy, and here we have written about one example. There are many examples. You can write any example in law of conservation of energy. Okay, total energy will be same.
Okay.
Okay, so basically total energy at the height, total energy was what? It was maximum potential energy but zero kinetic energy. Now when it struck the nail, what happened? Okay, now the kinetic energy is maximum. Okay, and that maximum kinetic energy was transferred to the nail. Clear? Due to which the nail
Yeah.
got penetrated inside the wooden board. Clear about this? You can give other examples as well. For example, the CFL which you are using in your home, the electric bulb which you are using in your home, what it is doing? It is taking the light energy, it is taking the electrical energy, and that electrical energy is getting converted into light energy, heat energy. Okay, when you touch the CFL, you can also feel that some warmth. Yes or no? You can feel some heat.
Yeah.
Okay, so along with the light, heat is also eliminated. Okay, because heating effect is also there with the current. Clear about this? So electrical energy is getting converted into light energy and heat energy as well. So this is also the example of law of conservation of energy. Energy is not getting destroyed, it is constant. Total energy is constant, but it is getting converted, getting transformed into other types of energy. Okay, and other types of energy are taking their magnitudes, own magnitude, such that the total energy is constant. Clear about this?
Yeah.
Okay, let me give you one more example. Let us suppose the electrical energy is getting converted into light energy and heat energy. Okay, suppose this is your electrical energy. Okay, EE means electrical energy, and it is getting converted into light energy, okay, plus heat energy. Okay, let us suppose this electrical energy was how much? It was around 500 joules. Okay, so this 500 joules will always be there. Okay, it is not going to get destroyed. It is not going to, the total energy will be always 500 joules. Why? Earlier, when electrical energy was not conserved, it was 500 joules. Now when it was converted into light energy and heat energy, okay, it will be broken into parts, but it's still the sum will be what? Still the sum will be 500. Let us suppose this light energy is taking 450 joules, right? So the remaining heat energy will take 50 joules. Still the combination is 500, right? Okay, so this is the law of conservation of energy. Energy always remains conserved. Total energy will always remains constant. Okay, it will just changes its forms. That's it. Clear about this? There are many examples which you can use. We have discussed about many examples, right? The conversion of electrical energy into chemical energy into light energy, right? Different examples we have discussed, and those are given in your book. You can use any example if you want. Okay, clear?
Yeah.
Very good. Now after this, as we have discussed about the principle of conservation of energy, now we will discuss the proof of this. We will do the theoretical verification of this. Okay, how we will prove that this is the correct statement. Okay, because physics, it demands proof. Okay, so basically what we are going to do, we are going to give a proof here. Okay, we are going to prove it mathematically that the energy remains constant, total energy remains constant. Clear about this?
Yeah.
Okay, so basically for this, what I'm going to do, I'm going to do the theoretical verification. Okay, theoretical verification of law of conservation of energy. Theoretical verification of law of conservation of energy. Okay, and for this what we will take the potential, because through potential energy and kinetic energy, this can easily be done by taking potential energy and kinetic energy into account. Both of these are called as the mechanical energy, their sum is called as the mechanical energy. Okay, so here we will prove that the mechanical energy at all the points will be constant. The total energy at all the points will be constant. Here we will prove this. Clear about this? Okay,
Yeah.
so theoretical verification of law of conservation of energy, and you can also say it that theoretical verification of K plus U is equals to constant for freely falling body, constant for a freely falling body. Clear?
Yeah.
Now what do I mean by this? So for this, what I'm going to do, I'm going to take an object of certain mass. Let us say you are taking this ball. This ball is of certain mass. Let us say it is of m, right? Let us say this mass is m. Okay, m, small mass m. Now what will happen? This same mass will be at this position. Right now it is at position A, and after some time it is at position B, right? And then at the last it is at the ground. Clear about this? Easy?
Yeah.
Okay, let me shift the positions a little. I think now it's fine. Yes. Okay. So this is the body of mass m. I have written. So let us suppose the total height at this. So this is your ground. Okay. From the ground, what is the total height? Let us say it is equal to h. Okay. This is your total height from the ground, and it is equal to how much? Height. It is equal to h. Okay. Clear about this?
Yeah.
Now, let us suppose this ball is at position A. So I am writing here in another color. This ball is at position A. This body of mass m is at position A. Now after some time it is at position B, and then at last it is at position C. Clear? Understood?
Yeah.
Okay, so from A to B, let us suppose the distance between A and B is how much? It is equal to x. So what will be this distance? Tell me. Between B and C, it will be equal to, so bigger one minus a smaller one. Tell me what it will be.
H minus X.
Very good. H minus x. Clear about this? Okay.
Yeah.
So this is your h, this is your x, and this is your h minus x. Clear? Now what we will do? We will write some of the important considerations which we have taken. Okay. So I am writing some important considerations. You can copy this down. Very important. Okay. Clear? So what we are going to do? Let there be a body of certain mass. And I am writing here. Let there be a body of certain mass, and that certain mass is equal to small m. Clear? Okay, at position A, that is at the top. Okay, at the top. Understood? Right. Therefore, so potential, therefore at A, what will be your potential energy? At A, potential energy, let us suppose potential energy will is at A B UP. Okay, UA, potential energy at A, let us say that it is equal to what? Tell me. UA. Okay, it is equal to UA. UA means potential energy at A, because potential energy is represented by the symbol U, and UA means potential energy at A is equal to how much? Okay, you know very well that at the top, because of the height, potential energy will be maximum, but kinetic energy will be zero, right? So what will be the potential energy at A? Tell me. Tell me what it will be. You have raised the object of mass m to certain height, so you are doing the work against gravity. So that work against gravity will be stored in the form of the gravitational potential energy, right? So what will be the formula for potential energy at point A? Tell me. Mgh. Okay, this is your total height. So you have done the work in raising this ball of mass m to a height h. Okay, we have done the derivation. Remember, you can see that derivation as well. So the total potential energy will be what? Mgh, right? Potential energy at A will be equal to mgh. Equation number 1. Okay, don't take it as equation number 1. Let's find out the kinetic energy. So what will be the kinetic energy at A? Tell me. Kinetic energy at A.
It will be 0.
So Ka will be 0, because at height the kinetic energy is 0, because the object is at some height, it is at rest. Okay, so it will be 0. So what will be the total energy? Total energy at A. So total energy will be
yes, like UA plus.
Yes, so we will take total energy as EA. Okay, and EA will be equal to K plus Ka plus UA, right? So EA will be equal to Ka plus UA, and Ka plus UA means Ka is 0 and UA means mgh. So your total energy will be equal to what? Mgh. Yes or no?
Yeah.
So this is your total energy at position A. Okay, so we are going to write some important considerations here. So you can see here at this position A, we have the potential energy, which is what? Mgh, right? And your kinetic energy at point A is 0. So your total energy is basically equal to how much? Mgh. Understood?
Yeah.
Now we will consider point B. Okay, at point B, what will happen? Okay, so I am writing here. So now what will happen? Now this ball be dropped from the certain height. Let this ball be allowed to drop from certain height. Let this ball be allowed to drop from certain height. Okay, I am not able to write. Let this ball, or let this body of mass m be allowed to drop from certain height h. Okay, to which position? We are dropping it from position to position. to position B, okay, and then at last to the ground, that is at C. Understood? First of all, we will be finding the total energy at B, and then we will be finding the total energy at C. Therefore, first we will take the total energy at B. Okay, therefore at B. So what will be the total energy at B? Okay, so first we will find the kinetic energy, because potential energy will be converted into kinetic energy, right? But total potential energy will not be converted. Some potential energy will still be there. Okay, clear about this? So let
Yeah.
us find out the kinetic energy. Therefore, kinetic energy at B will be how much? Kinetic energy. Tell me what it will be. Half mv square kb.
Yeah.
Half mv square. Okay, so let us say it is mvb square. Vb square means velocity at point B. Okay, for the body. Clear? So kinetic energy half mvb square. Now you don't know the value of this vb, right? Vb square. Okay, so what you will do, take it as equation number 1. Clear? Now what you will do, you will find the value of Vb. So here you can see that the our when the body is at some height, the initial velocity is 0, u is equals to 0, and then after that it will be allowed to fall. Okay, so basically we will find the value of Vb. So for that, what we will use? Tell me what we will do. If we want to find the value of Vb, what we will do?
We like. I'm not sure.
You will use the equations of motion. Simple. Okay, so you can use third
Okay.
equation of motion. Okay, using third equation of motion. Third equation of motion. Okay, so your third equation of motion is what?
Okay.
V square. So V square is Vb square minus u square is equals to
Is equal
2a
to 2 AS.
2as. But here you can see that this use a is equal to g. Okay, because it is the condition of free fall, and this s is equal to how much? It is equal to, tell me what will be the value of it? Will be equal to x, because we have taken at b the distance between a and b is what? X. Okay, you can see here it is that it is x, so s we will be taking equal to x. Okay, understood?
Okay.
So it will be what? 2gx. Understood? So you know very well that u is equal to 0. Since u is equals to 0, therefore your equation will be what? Vb square is equal to how much? 2gx. Understood?
Yeah.
Now what you will do? You will substitute equation 2 in first, right? Substitute equation second in first. What you will get? Tell me when you will substitute this. Very easy. Okay, so kinetic energy will be equal to how much? Kinetic energy at B will be equal to how much? Half m Vb square. What was the value of Vb
V
square?
square.
Tell me. Tell me what was the value? See, Vb square is equal to how much?
2GX.
Very good, 2gx. Okay, so it is equal to 2gx. Now 2 and 2 will be cancelled. So our kinetic energy is how
Yeah.
much? 2gx. Okay, so this is your kinetic energy. Make this kinetic energy as equation number 3rd. Clear?
Yeah.
Now, what about the potential energy? We don't have the potential energy. Now, what will be the potential energy? Potential energy at point B will be how much? Tell me. Potential energy. Okay, so we will be taking it as UB. It will be how much? Can you tell it from the diagram? How much will be the potential energy at point B? Potential energy is because of some height. Yes or no?
Yeah. So it will be 0
Why it will be 0? It will not be totally 0.
because
No, not
yeah.
will be it will not be totally 0, because it will be totally 0 when it will strike the ground. Okay, when it will be totally on
Okay.
the ground. Okay, there will still be some of the potential energy left. Okay, although it is getting converted, but still there will be some potential energy. Okay, so what will be the potential energy at B?
Um, it could be like mgx minus x.
mgh minus x. Very good. Why? Because it is at position b, and potential energy is because of some height. So this mass b, okay, this ball of mass m, okay, is at h minus x height from the ground, right? So that is the reason why your potential energy
Yeah,
will be what? Potential energy will be mg into h minus x, right? So what will be the value of ub? Ub will be equal to mgh minus mgx. Clear or not?
clear.
Okay. So this is your equation number 4th. Understood? So what will be your total energy?
Yeah,
Therefore, total energy, total energy will be at EB, at the position B. We are finding total energy is equal to KB plus UB, kinetic energy plus potential energy. So EB will be equal to how much? Can you tell me? Kinetic energy is 2gx, right? No, not 2gx, mgx.
yeah,
I have written it wrong here. Mgx. Okay, it is mgx. Okay, so basically it is how much? Mgx, yes or no? Mgx
yeah,
plus ub, mgh minus mgx. So mgx and mgx will be cancelled. So your total energy is how much? Eb. Your total energy at b is also mgh, right?
yeah,
Clear? So let us say this is, so this was eb. Okay, ea, let us, you will take ea as equation number first in roman numeral. Okay, first, and take this total energy at b as equation second in roman numeral. The reason I'm writing in roman numeral is that you will not get confused. Okay, now what we will do, we will find the potential energy and kinetic energy at c. Clear? Okay, now just look at this
yeah.
now just look at this diagram. So at b, what is the potential energy at b? Tell me. Potential energy at b will be mg into h minus x, and kinetic energy at b will be equal to how much? Mg x. Okay, and total energy is how much at eb? It is equal to mg h. Okay, see here, at a the energy is mgh, at b the energy is mgh. So at both the points energy is same, energy is conserved. Okay, and at the last point we will also find that the total energy will be conserved and our law of conservation of energy will be proved. Okay, very easy.
Okay.
Okay, so basically at c what we will do, tell me. At c, so you have to find the potential energy at c. So potential energy will be 0, yes or no? Potential energy at c will be what? Tell me. At c,
0.
so let us say it is uc. Uc will be equal to 0, yes or no?
Yeah,
Now what about kinetic energy? Kinetic energy kc, kinetic energy, it is equal to kc, and kc is equals to what will be the kinetic energy? Let us say the velocity at point c is half m vc square. Okay, where vc is what? Okay, vc is velocity, final velocity, always remember this, final velocity of the object at c. Clear? Understood?
yeah,
So now what we will do, let us say this is equation number uh, at c. So at c what we have taken so far, this was equation number 1 2 3 4. So total how many equations we have taken in the previous case? Total 4 equations we have taken, right? So let us say this
yeah.
is equation number 5th. Okay, so kinetic energy is half mvc square. Now you will find the value of vc. So what will be the value of vc? How you will find the value of vc? Tell me. How you will find?
Um,
Very easy. again the same thing. We found the value of VB through what? With the help of,
the help of um
are you
with the
focusing,
help of UB.
are you focusing on the class? uh,
Yeah.
yes, so focus it more, okay, because we discussed this in the previous example as well. So how we found the value of VB? Just look here, we used, what is this?
The third equation of motion.
Yes, okay, now we will use the same equation of motion, okay, third equation of motion. So using third equation of motion, third equation of motion. So what is third equation of motion? What is it? V square,
V square minus
yes,
U
VC
square is equal
square
to
minus
2AS.
U square is equals to 2. So basically A is equal to G because this is free fall, right? Okay, and S will be equal to how much?
Yeah.
It will be equal to, see here, the distance is how much? What you will do? It will be equal to H, total H, okay, 2GH. Clear? 2GH.
Yeah.
So VC square will be how much? 2GH, right? Okay, now what I'm going to do? 2GH. So U is equal to 0. So I can write VC square minus U is equal to 0 is equals to 2GH. Why? Since U is equals to 0. Clear about this? Your U will be equal to
Yeah.
0. Okay. Therefore, your VC square will be equal to 2GH, right? Equation number
Yeah.
6th. Now what we will do, you will substitute equation 6th in 5th. Substituting equation 6th in equation 5. Okay, what we will get? Tell me. So your kinetic energy will be how much? Kinetic energy Kc will be equal to half m, or what is the value of Vc square? Tell me.
2GH.
2gh, and 2 and 2 will be cancelled. Your answer will be what? Tell me.
It will be MGH.
Mgh. So Kc basically is equal to how much? Kc is equals to mgh. So let us say this is equation number 3rd in Roman numeral. So from equation, therefore from equation 1st, okay, not, don't take it as equation 3rd right now, because we also have to find the total energy. Therefore total energy will be what? Total energy at C will be equal to EC. Total energy at C is equal to AC, and it is equal to Kc plus UC. Yes or no? So total energy will be how much? AC is equals to Kc is mgh plus UC is 0, right? So EC will be equal to mgh, which means energy at all the points is same. And what does it tell us? Tell me. Let us take it as equation number 3rd in Roman numeral. Okay, so what does it tell us? Tell me.
That the
Tell me.
that it tells us that the like MGH is the formula for
Oh
the
God, you are very stressed, I think today. Okay, I don't know what has happened to you. From equations 1st, 2nd and 3rd, you actually have found out that energy, total energy at all the points is same. It is equal to
yeah.
mgh. Okay, which says that energy is conserved. Energy is not changing. Although energy basically is same. Only energy is getting transformed from one form to another form. Potential energy is changing into kinetic
Yeah.
energy. Okay, only this is changing. Energy is getting transformed, but total energy is conserved. It is equal to mgh. Clear? So from equations 1st, 2nd and 3rd, what we can say? Okay, it is clear that total energy, total energy, okay, which is equals to EA, which is equal to what? mgh. Total energy at all points are at all points. And what are the points? A, B and C, right? A, B
Yeah.
and C are same. What is it? That is total energy is equal to mgh. Okay,
Yeah.
clear? That is total energy is equals to EA is equals to EB is equals to AC is what? It is equal to mgh. Okay, thus energy is conserved. Okay, energy is conserved and law of conservation of energy is proved, is verified. Clear? Conservation of energy is verified. I hope it is clear to you.
Yeah.
Okay, clear?
Yeah.
Now after this I will give you time to write, don't worry. Okay, I will give you the time to
Okay.
write. So now we will be discussing about the, so this was which heading we have discussed. First we discussed about the law of conservation of energy, it was heading number 1. Okay, now this was heading number 2. Okay, theoretical verification was heading number 2. So I'm writing here, this is what? This is your heading number 2, right? Heading number 2. And after this we are going to discuss the graph. Okay, graph for the law of conservation of graph for that free fall which you have discussed. Okay, clear? So third important thing, which is your graph. Okay, so what will be the graph now? We are going to discuss this. Okay, so conservation of mechanical energy in motion under gravity. Graph depicting what? Conservation of
Okay.
yes, conservation of mechanical energy. Mechanical energy means kinetic energy plus potential energy. Okay, mechanical energy.
Yeah.
Okay, under what? Mechanical energy in motion under gravity. Clear about this? So here you will do
Yeah.
this graph. Okay, so what will be this graph? Let me tell you how to draw this graph. So here what we will do, we will take the y-axis, and then we will take the x-axis. Okay, on y-axis what we have? On y-axis we will take energy, and on x-axis we will take the height. Clear? Above the ground. So on x-axis I am taking height. Okay, on x-axis I am taking height above the ground. Clear? Above the ground.
Yeah.
Okay, and on x-axis what we have? On x-axis we have the energy. Okay, energy. Okay, clear or not? Okay, so
Yeah.
this will be your origin, zero height. Okay, this will be your origin, zero height and zero energy. Okay, now this is your point A. Let us suppose this is your point A, this is your point B. Okay, and this one basically is your point C. Okay, at the origin you have this point C. Okay, clear about this? Now,
Yeah.
so basically you know very well that at point A you have the highest potential energy, right? Okay, so at point A your potential energy is highest, mgh. Okay, maximum potential energy. So what we will do, this potential energy will be maximum here. Let us say it is mgh here. Clear? mgh.
Yeah.
Okay, this is the total energy actually. Okay, so basically what will happen, this is the total energy. Now when we will come down, okay, when we will come down towards the ground, the potential energy will be converted into kinetic energy, yes or no? So here your height is 0, okay, as you can see. Okay, this is your kinetic energy. And then here what you are doing, you are taking the potential energy. So your potential energy from point C, so when you will go above point C, what will happen, your potential energy will increase, right? Like this, yes or no? Your potential energy will increase. Okay,
Yeah.
let me draw it again. Yes, now this is fine. Okay, your potential energy is increasing, so this is your kinetic energy. Okay, I'm writing here, this is what, this is your kinetic energy. Okay, so when your body, okay, this is your kinetic energy. Okay, this is point C, this is point, I'm writing again, this is point B, and this is point A. Clear? That your basically body is coming to point A. So when your body will be coming to point A, kinetic energy will be increasing, okay, and potential energy will be decreasing. So this is going to be your kinetic energy, right? Now when your body is going from point C to point A, then your potential energy will be increasing and kinetic energy will be decreasing. Simple. Potential energy. I hope it is understood to you, this graph. Is it clear? Very
Yeah.
important. They will ask this graph. So, and this mgh is what? I'm not getting colors. Okay, so this is mgh. Okay, this mgh is basically what? It is your total energy. I'm writing above. It is what? It is your total energy. Okay, this is your graph. And this high, this b means, okay, I have to take the b at this position. Okay, because b is not in the middle, so I have to take the b at this position. Okay, let me take b at a little middle position. Clear? So I'm going to take b here. Okay, at in the middle. So b will be equal to how much? It will be equal to half of the height h by 2. Yes or no? Okay,
Yeah.
so this is your graph which depicts the conservation of mechanical energy and the motion under gravity. And if they ask you to draw the graph between kinetic energy and potential energy for the motion under gravity, how you will draw this? You will draw like this. I hope it is clear to you. Okay,
Yeah.
any problem till here?
No.
No, really very good. Okay, all right, so this is it. Just copy this down. Okay, I'm giving you time, it's really very important. All right, then just copy it down. Thank you. Copy it.
Okay. Thank you.